Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 16th, 2025, about 3 days ago. The standout result is that a transparent test-time compute pipeline reaches an international Olympiad in informatics gold medal using only open-weight models, with a submitted score of 446.75, beating the gold threshold of 438.3. The paper is titled, Scaling Test-Time Compute to Achieve IOI Gold Medal with Open-Weight Models. And as we'll see later, the implications for open model evaluation are pretty exciting. In short, the work introduces GENCLUSTER, a 4-stage test-time compute framework that scales with more generations, outperforms simple selection baselines, and improves reliably under the official submission limits. Alright, the introduction highlighted the gold level result. Figure 1 now lays out the GENCLUSTER pipeline for each IOI subtask. The process starts with the model generating many C++ solutions, while separate generators and validators create test cases that drive execution. Outputs form behavioral clusters, which capture distinct solution strategies. A tournament then ranks cluster representatives, and a round-robin submission policy selects top candidates under the 50 submission cap. Well, the previous figure outlined the selection pipeline. Figure 2 shows how different open-weight models translate that into scores as generation counts rise. The GPTOS 120B model climbs from about 335 at 50 generations to roughly 442 at 1,000 and near 500 at 5,000, which clears the gold threshold. Other models improve too, but trail, and the green Quen line starts competitive at small budgets, yet scales less strongly. Metal lines mark bronze, silver, and gold. So, the previous figure compared models. Figure 3 tracks one model as generation counts grow. The chart contrasts submitted scores under the 50 submission cap and unconstrained score at K. Both curves rise, with submitted moving from about 332 to 447, while unconstrained reaches roughly 500, which shows a widening selection gap at larger pools. The gold threshold sits near 438 and gets crossed only at 5,000 generations. A dashed reference near 533 marks the OpenAI report for context. Okay. The previous figure showed the widening gap between submitted and unconstrained scores. Table 1 now compares selection strategies under the 50 submission limit. GENCLUSTER tops the chart at about 447, while the score-based variant reaches about 441. Random and longest trail at roughly 300 and 277, and cluster size or cluster majority only reach around 300 to 314. Using the longest trace as the representative and ranking by wins gives the best reliability, which suggests both clustering and tournaments matter. Alright, Table 1 had selection strategies. Figure 7 plots score at 5,000 versus maximum tokens across models. The black GPTOS 120B curve keeps climbing through roughly 112,000 tokens, which shows clear gains from longer reasoning. The green Quen line levels off near 48,000, and the blue DeepSeek line plateaus around 64,000. The gray GPTOS 20B improves steadily but trails, so bigger budgets favor the larger GPTOS family. Alright, the previous figure highlighted token limits and scaling. Table 2 summarizes per problem scores and overall rankings across the contest. GENCLUSTER records about 447 total points at rank 26, which meets gold under the official rules. OpenAI reports about 533 at rank 6, showing a substantial lead over open-weight results. The top human, Hengxi Liu, posts roughly 591 at rank 1, while Maxim TSOY scores about 437 at rank 29 for silver. Wrapping up, 2 takeaways stand out. Scaling test-time compute with GENCLUSTER reliably lifts open-weight models to international Olympiad in informatics gold, and behavioral clustering with tournament ranking is the key ingredient under strict submission limits. The broader implication is clear. Transparent, reproducible compute can narrow the open versus closed gap. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.